Okay, so this video is going to talk about properties of algebra. I wrote all this out and then the computer deleted it on me, so let's just go over it while it's still here. So we have a few properties. We talked yesterday about the commutative property. See this? It means that in any order you can add a plus b or b plus a. It doesn't matter, it's the same. And this is commutative as well. A times b and b times a, they're all the same. Now that means 2 plus 3 equals 3 plus 2. And that's right. And that means that 4 times 6 equals 6 times 4. So this is right and this is right. So that's good. Today we talk about the associative. It means that you can do it in any order, addition and multiplication. So you can add a plus b first, and then add c if you want. Or you can take a and then add the b plus c, and then take it together. So here a plus b, if we said 1 and 2, that'd be 3 plus 3, 6, right? Here, if we said a is 1 again, right? 1, 2, and 3 for c. 2 and 3 for c. A is 1, but then we add the b and c first, we get 5 plus 1 is 6. So you see, it doesn't matter what order we add in, it works. So this is your example. Okay, and here's your example for this one. This is a multiplication associative property. So a times c and then times b, or c times b and then times a. Doesn't matter what order. For this we'll use 4, 2, and 3. So a is 4, c is 2, b is 3. A is 4, c is 2, b is 3. A times c, that'd be 8 times 3. 8 times 3 is 24. Okay. C times b, that'd be 6. 6 times 4, 24. So we see once again that it works. Okay. Let's go down a little bit here. Talking about identity properties. Things that you can add something but it keeps its identity. So here's an identity property of addition, and this would be the 0 property. So we'll call this 0 property of multiplication. So if we add 0 to anything, it stays the same. 9 plus 0 is 9. Negative 11 plus 0 is negative 11. Negative 2xzj plus 0, negative 2xzj. Stays the same. How about the 0 property? You can multiply it by 0, you'll still get 0. Anything. Okay, so 9 times 0, 0. 0 times negative 11, this is using the commutative. Doesn't matter what order it's in, right? Still 0. 0 times all of this, 2xzj, doesn't matter what it is 0. Okay? A couple more. 0 property of addition, or the additive inverse. X plus the negative x is 0. 2 plus the negative 2 is 0. What if x was negative to start? Well, you'd change the sign. So negative 2 plus a positive give you a 0. Here we have x times 0 is 0. So now we're going to recap everything we've talked about so far. So we go to 2 screens here. Let's see what we have. Good. Okay, so here's our recap. We can add them. If we can do a plus b, that's the same as b plus a. Doesn't matter what order, doesn't matter what comes first. So that means that 2x plus 1 equals 1 plus 2x, keeping the number in front of it. Okay, keep that in mind. Let's do a couple more of these. A times b is b times a, so that means 2z times 4 would still be the same as 4 times 2z. Doesn't really matter, does it? Okay. We can add them and then add the second part. We talked about that. We can multiply them and then multiply the second part. It doesn't matter how we associate it. This is the associative property. We talked about that just now. Okay. And now we have adding 0 keeps it the same. Multiplying 0 makes it go to 0. Okay, we talked about those. Adding the inverse, the opposite number, gives you 0. Okay. And multiplying by 1 gives you itself. That's an important one right here. So we're honing in on that for a second. Some number times 1 is going to be itself. So we could look at some examples of that. Okay, we could say, looking over here again, 10 times 1 is 10, 9 times 1 is 9, negative 30 times 1 is negative 30. Okay, so here we're getting itself. So that's important. And then here, a couple more properties, one more property we're going to show and then give a couple examples. So these are your examples. Some number divided by itself is 1. 2 divided by 2 is 1. Negative 3 divided by negative 3 is 1. 4 divided by 4 is 1. You're going to get 1. So here's how this right here applies to algebra. So come on up here. Let's see if we can do that. There we go. That's kind of cool. 2x equals 8. When you start with this equation, 2x equals 8, you know you divide by 2. Most of my algebra students should know that right away. When you divide by 2, these 2's cancel. But what is that meaning? 2 divided by 2 is 1. So let's just take this 2 divided by 2 and make it 1. 1 times x equals 4. Keeping our scale balanced. See that little diagram? So, in other words, we have 5 here and we have 5 there. And if we wanted to add 2 to both sides, we'd have 7 and 7. So back to this. 8 divided by 2 is 4. We have 1x, because we know 2 divided by 2 is 1. 1x is just x, right here. Something times 1 is going to be itself, so it's just x. So x is equal to 4 is how you get the answer to that equation. That's good. Now this is the multiplication type. What about the adding and subtracting? How do we cancel out there? So in this case we have x plus 9 is 20. So if we had to subtract 9 from a positive 9, we would wind up getting 0. Okay? And if we take 20 minus 9, we'll get 11. So in this case, x is equal to 11.